What's going on, and happy Sunday, my people. Welcome back to Software Sundays. I am KD, the host of the show, and today we're going to be talking about a few of the most interesting events that happened with technology and discuss some of the ways that we can improve as engineers as we continue along our career. So with that being said, I'm happy to be here. Thank you for joining. Let's get it started. So to start, I wanted to highlight some news that I heard from Google Cloud and the fact that they announced a $5.5 billion investment into Germany in order to build data centers. And this is an extension of their already significant footprint inside of the EU in a variety of different countries. But the interesting parts about this facility is that it reminds me one about the data sovereignty laws that we're starting to see popping up in different jurisdictions with with data becoming the new gold and privacy becoming more of a greater concern to citizens in their countries. We're starting to see the geographic location of where that data is being stored being an important consideration for not just hyperscalers and cloud companies, but the users of those platforms, in order to make sure that they understand how their data is being secured and protected. This move helps Google to comply with some of those data sovereignty laws, as well as extends their abilities, their customers' ability to comply with those laws, because now you have a larger footprint in the region, and you can say, hey, we have more data being stored here. So the need for it is probably fed by the fact that they're may have been made reaching a capacity or at full capacity for their existing data centers in the area, and so they're looking to build those facilities out. Another interesting initiative going on with that new investment, and they've done pilots in some of their French data center locations, is the fact that some of the energy, we all know, or it's very common knowledge, that data centers they require a significant amount of energy to keep running, and that has been detrimental to some local communities, and Google is thinking about ways to make that that challenge less difficult and burdensome for those communities. And so the increased energy cost of having a data center in your neighborhood can start affecting your ability as a family or as a community to afford heat, afford electricity for your home computers or your lights and other things that you may require. It could be medical devices inside of your area. When you have a data center pulling a lot of that energy and increasing the demand, the costs understandably go up. Google has worked and partnered with another company to redirect some of the heat generated by their data centers to be able to use to heat, I think, over 2,000 homes. And so when we're thinking about innovative use cases for almost like two birds with one stone, you have this data center that you need in order to keep up with the AI revolution and industrialization, and provide some of the critical services that people need, but the challenge with the cost uh, to the families that live around these data centers can be mitigated and lessened by redirecting some of that heat into those homes to give those families a lower bill, right, for heating their home. And there may be other use cases for how you can kind of redirect that heat to be something more beneficial, because the heat generated by these data centers is also another challenge that they face when developing them, because it's not just keeping those machines up and running 24/7 and having multiple machines up and running. It's the fact that you have to keep all of these hundreds and thousands of machines cooled that entire time. And that requires ACs and other cooling technology that, again, generates a lot of power. So I thought this was pretty interesting that Google has even thought about this as a potential solution for how they can continue to innovate and grow while also giving back to the community and doing some social good. So kudos to them and the team that worked on that to get that partnership started. And I'd like to see how it goes in the future, because that's not just a challenge we're seeing inside of Germany. We're seeing that all over the globe with every community and region. So when you think about data centers, we're not just thinking about the fact that there are massive warehouses filled with computers that need to be kept online and running. We're thinking about how do those data centers actually impact the communities and the countries and nations that rely on them. And it could be from data privacy and resilience, because a lot of our mission critical services are on the internet now, right? They need a home to run out of. So the data centers are key for that, but also maybe they are the solution to how do we make housing or energy costs more affordable. And maybe it's not so much a solution as a way to not let it get so much out of hand. So keep an eye on that. Maybe we might see AWS do it in their, or AWS, Azure, or any of the other cloud providers that find other interesting use cases for the output of some of their services. And moving on into the crypto side of the house, I saw that there's a new draft being released by the Senate Agriculture Committee that is supposed to define some crypto oversight and oversight for the CFTC. This bill and the bills that they're working on, because it hasn't actually been ratified, the bill is supposed to define certain terms like the blockchain and NFTs and different concepts that will apply under the Commodity Exchange Act. And it's part of an ongoing effort to make sense of and regulate some of the technologies related to cryptocurrency and blockchains and Bitcoin, and not just Bitcoin, but all of the other cryptocurrencies that are living on Bitcoin, on blockchains. And it's not just something that's going to affect the, it's not just about finance, right? You know, decentralized finance, DeFi, is a large use case that blockchain has been pushing, or that the blockchain and the Web3 technologies have been pushing and elevating. But it's also things like smart contracts and NFTs, and how do we tokenize some of the assets that actually exist in the real world. And this bill is just the start to see how do we make sense of certain of the things that we're seeing and the changes that we're seeing in the market. And honestly, it's not a simple matter to solve for, and has had, even the current drafts have had some discussions and back and forth between policymakers and the leaders of the Web3 companies that are trying to make sure that the terms inside of these bills are not disruptive or stifling for the innovation and development in the space. One of the major battles inside of the bill relates to the developer protections and responsibilities for developing some of these technologies. There have been a number of cases related to blockchain companies or exchanges and other technologies all related to blockchain and Web3 that have almost it's put the burden onto the developers to make sure that the technology is not being used in a negative way or in a way that it could potentially hurt the community. But because the technology is so new, it is a little difficult for the companies to actually comply with these regulations. And I mentioned it last week with the AI Act in the EU and the fact that certain regulations and requirements placed on a company make it more difficult for new entrants to enter that space and innovate. Because not only do you have to build and engineer new solutions, you're now having to deal with all of the red tape and the compliance requirements needed for you to execute in that space effectively. And so that's, again, higher cost and higher complexity when at this time you don't even know what the solution is really going to look like when it actually gets to market. And you may be still searching for product market fit and still iterating on that initial design. So having some clarity on the different terms and the regulations that these companies will have to comply with will be super helpful for the space and just make it a lot easier for everyone to build there. An additional thing that I thought about with the fact that the bill, I was totally confused about the fact that the Senate Agriculture Committee was the one updating these bills or creating this draft. And that has been a discussion that has been had by different policymakers to understand who is actually going to be responsible for the different sections inside of the bill. The Senate Banking Committee also has created their own version of this bill to help add some clarity to the space. And that makes sense for any of the financial related aspects of the bill, but I'm sure there are other areas that relate to blockchain and Web3 and NFTs and smart assets or smart contracts that may require different thought leaders and different backgrounds to make sense, because it's not just the fact that we're adding some new technology. The blockchain is not really something, to me it doesn't feel so new. The idea of decentralized nodes that use cryptography to secure data and communicate using some shared protocol is not new. That has been and existed in even the Web 2 infrastructure. The difference is when we move into the blockchain is now we don't have, or we're moving away from the centralization of some of these services and the data. We're trying to break up the ownership of these services and give everyone a stake inside of the technology that is shaping the industry. And in breaking up the existing systems that we rely on, we have to think not just bottom up. We're changing the computer to be from this type of computer or this centralized heavy large computer to this decentralized network of computers. We have to start thinking from the top down. What is the process that's going to change now that we have a transparent blockchain or ledger that can record the ownership of a property? How do we keep track of the asset and prevent fraud? Whose signature is reliable on the blockchain? Because if it's public and anyone can add to it and anyone can see it, how do we make sure we're not leaking specific data that should be private? So it's not just having the terms defined and having an understanding of who is responsible for what. We have to really think about the fact that our entire society and the way we do business and the way we communicate and the way we have and rely on our services, it can potentially change. And so, yeah, that's definitely not a simple matter. And I know they're expecting, or I think the president wanted this bill to be signed, I think, over the summer, and they're shooting for the end of the year right now, but it will probably take into 2026 to actually come up with something more final that everyone on both sides of the aisle will be comfortable signing. So let's keep an eye on that as we move forward in the future. And in some cyber news, Anthropic released a report on one of the first AI-orchestrated cyber-espionage attacks, which basically means that AI was used recently to conduct a series of penetrations against multiple targets. And those targets were in the financial services sector, primarily financial services sector, maybe a few in some other critical industries. And we're seeing the fact that a lot of that attack was automated, at least the initial aspects. Of course, the targets were defined by the operators, but the fact that the initial credential discovery, the initial scanning, and all of these other steps that would normally require a human to do, and as such is more manual, required more time. We're starting to see the fact that AI is able to handle some of these tasks, which really just means that you're going to start seeing these attacks happening faster and faster. And they're going to be more sophisticated because it's not just a human having to automate, a scan. We're having a human direct an AI to automate the scan, but also it has the ability to dynamically react and adjust to certain changes inside of the target and its own environment. And so, as a cybersecurity expert or a SOC, if you're an SOC, or you're even thinking about how do I build tools to prevent some of these attacks, you have to start implementing AI now on the defensive, because we're no longer just going to see simple attacks that happen from manual commands, and the scans that you may have for a manual attack may look totally different now when you start throwing AI into the mix, because these systems can learn on the fly how to potentially stay under the radar. And one of the interesting aspects of this attack was the fact that models like I think Claude and the other Anthropic models and most LLMs, they have content filters that are supposed to prevent any type of misuse. Misuse being any type of privacy violations or any type of blatant manipulation of a target or a human, and other factors that have been defined as no good to allow a computer to do. They've been, or they're supposed to have been, blocked inside of these systems. The attack was executed and orchestrated in such a way that none of the content filters and the blockers were actually flagged, at least initially. Eventually, due to the speed of some of these requests coming in, then the Anthropic team was able to discover, what was actually going on. But at first, when the orchestrator, the attacker, broke up the requirements that they needed into so many different steps, and they were able to engineer through prompting to convince the LLM that what they were doing was actually okay. So they tricked. I don't want to call it social engineering, but it's like a form of social engineering to trick this LLM into thinking that what it's doing is okay, and by doing so, prevent any of the content blockers from initializing. And so there was a lapse in security, and I won't even call it a lapse in security, but there was a gap and a vulnerability found inside of the LLMs, and that vulnerability it gave the orchestrators the ability to use the LLM to find other vulnerabilities in different target systems. And one of the interesting things about the fact that the AI was used inside of this attack was it used the same AI that we all use, right? And the AIs, LLMs that we all use are susceptible to hallucinations. And so this attack also was impacted by the fact that the LLM could hallucinate. And so certain things that it was trying and certain discoveries that it said it had made, it didn't actually make. And so it's still not extremely dangerous to the point where you can just give an AI a URL and say, hey, hack this bank or hack this person's phone. It may not have that level of sophistication, but it does give attackers who are able to, coordinate these different tools together, a edge over people who are not using those tools to help defend themselves. And so that was like an interesting part. Like the hallucinations still impacted the accuracy of the efforts, but it just shows what's possible with this level of AI. And we're going to continue to see improvements in these models as time passes. But one of the main things to consider is that this campaign followed the classic steps that most attackers do, whether manually or through automation. So the MITRE attack framework still applies to identify and break an attack chain from escalating and getting to be a damaging attack. So you can still defend your system, whether it's against a human or an AI, by understanding how do we break the chain early, how do we prevent initial access, how do we prevent privilege escalation, how do we prevent scanning. If you think about your system from that perspective, you can still defend yourself against even the most sophisticated attack. So keep that in mind as you're building and deploying and protecting in this current era. So let's get into some of the questions that we have this week about big tech and technology, and just learning a little bit more about the way the world works and how we can become master engineers inside of this world that we live in. So let's get started.
How does Amazon make money?
So when you think about Amazon, you may know about, the delivery and Prime and all of the things that most consumers use with the Amazon brand. But they have multiple segments in their business. The online store is one, that's how they started. Then they have third-party services for shipping and logistics. And as well as Whole Foods is under that Amazon umbrella with some advertising thrown into the mix. But one of their largest segments and the fastest growing is Amazon Web Services, AWS, which is their cloud computing arm, which is, going back to our data centers conversation in the beginning of the show, is the fact that they're providing compute to technology companies and other businesses to help them operate and execute faster. And so I think Amazon, AWS controls nearly 30% of the cloud computing market, and they were actually the first company to actually enter the space and start offering infrastructure as a service, platform as a service, and all of the other application and higher layer tools and services that they provide. And if you remember, a few weeks ago, they had that mishap where there was a configuration issue on their system that led to the disruption of, I think, hundreds, if not thousands, of different companies that were unable to do anything that day. So Whole Foods and Amazon apps didn't work. Ate Sleep, their bed stopped working. Companies like Coinbase had their own issues with doing transfers and transactions that day. And so you can see how integrated and ingrained AWS and their services are with the economy and the infrastructure we rely on. And the market that they're building it goes way deeper than Amazon Prime and Prime TV and all of the other services that we kind of are familiar with. They're in certain circles, and actually this is one of the cloud platforms that I actually prefer. I use AWS for all of my development when I'm building an app, because the services work and they're they get the job done. And a lot of the cloud concepts that I even initially learned, they originated on the AWS ecosystem. And they're continuing to build new features and functionality as different technologies uh, are released. So when you think about Amazon, think about AWS and all the other services that Amazon provides, because although AWS is not the largest, I guess, largest revenue driver in their business, it is the driver that provides the most profit and the best margins for their company. So at some point, we may start to see that AWS becomes an even greater portion of their business and definitely of the world.
How much does it cost to build an app?
So I know people might hate this answer, but it really does depend. And it depends on what the app needs to do, where it needs to be used, who needs to use it, how you put it all together, and why it's important. An app could be a web app, it could be a mobile app, or it could be an application that runs without any type of user interface. And it just runs on a computer somewhere in a closet or in a data center, just to bring that back up again. Your app could require payments integrations. It could require some integration with an emails, or you may have other things that it touches in order to provide the services that the app is designed to provide. And all of those are going to affect the technology requirements. It's going to affect the type of developer that you can hire for the project, because they may need to be more experienced with certain technologies versus others. And it's going to take more time, because you have to put all of these things together to get them to work. And so if you're hiring a developer, and you may even have a developer that only does front-end work, or you may have a developer that he's a back-end engineer, and then maybe both of those developers may not even be able to get it. Like, they may be able to build their very specific portion of the app, but they don't know how to get it into production or get it in front of a customer where they can actually use it on their phone or use it on a website that is accessible to the public. And even that's not even considering the fact that you may need to secure that system. And there are plenty of developers that don't understand security well enough to protect and comply with some of the regulations you may have to work with when handling PCI data or any type of PII data. When I start working with a new client who wants some custom software, the best thing we can do in order to discover how much that app will cost them is to really drill deep into what exactly they need and answer some of the questions that are important before anything else. Like, I'm not going to just give you an estimate and say, oh, your app will cost you $1,000 if you say you want to build a marketplace, because I don't know what type of marketplace you need. I don't know how many buyers and sellers will be on the marketplace. I don't know how many products will be on the marketplace, or how often they need to be updated, or even if you need to handle marketing on the marketplace or fulfillment on the marketplace. Like, these types of questions need to be asked before you think about how much it costs to build an app from a financial perspective, but also from a time perspective. Certain features cannot get deployed in a day or they cannot get deployed in a week. They may take a few weeks or a few months in order to comply with the regulations, to even understand which regulations do we have to even comply with. Not every app is the same. Not every solution is going to work the same. I can't create a cookie cutter solution that's going to work for a financial services company, a healthcare company, a dog walking company, and any other, industries. They're all going to require a different level of effort and design to build them, which is going to adjust the cost up or down. And when you think about how much it costs to build that app, you want to make sure you have a clear understanding of what needs to be built. In real estate and construction, that's primarily through, and even consulting, that's primarily through a SOW or a statement of work, and sometimes the statement of work is just a contract that says, hey, we're going to design it for you. But basically, I'm getting to the fact that you need to understand very clearly what is being built, because you can spend a lot of time building a thing that you think is the solution, but that isn't really the solution that you wanted. And a developer that's charging you per hour is going to charge you for every time it takes you to massage your vision into something that they can actually build. And you don't want to waste your money building the wrong thing. And on a personal note, you want to have a relationship with the developers or the builders of your app, because that relationship is going to affect whether or not you have the clarity necessary to understand what's being built and what needs to be built, but also whether they're going to, there's a such thing as a friends and family discount. And they may be able to help you go through the design without charging you. So if I am working with you and, we're just brainstorming for a while without me actually doing any type of development, even though the designing a lot of the time or the documenting of that design is something that I may charge a client for. If you just want to talk about the idea and how do we massage that into something more real and concrete, having a relationship with a developer will give you the best chance of not spending an arm and a leg on that product. Because at the end of the day, the price is the price, and the market defines that price. And so, you want to make sure you're understanding both sides of the market and the product that market is selling. Because that's your input cost, man. It's gonna cost you what it costs you. But good luck.
What should I study to be a great software engineer?
So, I would recommend everything. But really, that's only because at this point in my career, I'm learning that the things that I learned from not just computer science, but as a real estate investor, as a friend, as a brother, and even I've done some research into biology and how people are made up of, or what people are made up of, and how that process occurs. I've learned that there are some concepts that are applicable in any domain. And so having an understanding of history and art and philosophy can give you a stronger foundation as an engineer. But from a practical perspective, if you want to be an engineer, you need to understand computers. You need to understand networking. You need to understand logical reasoning and how control loops and conditions work. If if this then that, or if and else statements. You need to understand how to like a do this while, or when this happens do this. Like these are different logical uh, syntax and logical concepts that exist inside of programming and programming languages that make it possible for engineers to build really complex systems that manipulate and reflect the real world. If you're someone coming from a background that doesn't include any type of technology or any type of computer science and engineering, then I'm sure there is something inside of your background that is really going to help you make connections to the technology and the tech industry. Because even as a property manager, me understanding how to deal with contractors, or the flooring guy versus the plumber, or the electrician, that gave me a better understanding of my role as an engineer when I was building a DevOps pipeline, or if I was building a front-end UI or a back-end API. Having an understanding of the fact that these different components need to work together, and then there's an order of operations for how we're building this thing. You don't put the drywall on before you do all of the electrical work. And you don't do the electrical until you inspect all of the framing inside of the, not even inside of it, it's just inside, in the location. Me understanding construction from a physical real estate perspective allowed me to abstract and understand the technology that I was building in a digital perspective. And so I really recommend that you learn everything about computers, but then once you understand computers and you start learning about programming, you have to understand different algorithms. You have to understand how to sort, like different sorting functions, bubble sort versus merge sort or quick sort, the time complexity or the space complexity of these algorithms. You have to understand the structures you use in programming, from maps to arrays. Although I don't know if an array is really a structure. That's just, I don't know if that's a structure. But that would be a list. If in a lot of languages, an array is a list, or a list is an array. At least in Java, that is the case. So I think that's fair to say. But yeah, understanding the data structures that you're using, a stack versus a queue. So FIFO, or first in first out versus first in last out. Yeah, that's a stack, right? Because you can only access a stack from the top, versus a queue, you access it from the front to get off the line and the back to add on to the line. So understanding that structure of data and how you can use that to mimic the real world. You need to understand cryptography. You need to understand how do we encrypt data in transit. I remember in college, I had a cryptography class where we had to manually, like on paper, encrypt ones and zeros. So if you understand binary, right? 1 and 0 is the way computers represent data. I mean, you even need to take a computer architecture course where you have to learn what is binary, what is a binary system or number system. But imagine encrypting a string of ones and zeros using the SHA encryption algorithm and having to do all the math, the modulus division or modular division for that in order to say how do we like, and this is what's going on in the background whenever you send the message, and it uses HTTPS or HTTP with SSL or TLS. I think is the common algorithm now, or the common protocol now. But there's a bunch of calculations happening in the underlying computer that makes all the things we do seem easy. So at some point you will need to learn those concepts, and that doesn't mean you have to do it like you don't have to do that calculation every time, but it is helpful to understand what's actually going on. And so you want to know everything about a computer and how it works, and at least before you even get to like understanding AI and machine learning and all these things, just think about the computers, the classical computer, and how that works, and how you can wrap your head around that, and see how you can use programming to manipulate some of the classical functionality that you expect a computer to have.
Why are there so many rounds of interviews for tech positions?
So, my cheeky answer is to say that the people interviewing us have no idea how to measure technical acumen. But then the other side of me understands how difficult it is to know for certain if someone will be a good fit for an organization. And as a owner, the fear that leaders have of hiring the wrong person. So when you're going through and like after you apply for a position, you can expect a coding interview that is going to screen. Usually, in my mind, I just think they need to know that I know how to code. They need to understand, again, you need to know what an algorithm is. You need to understand time complexity, and just can you write code, right? And understand the syntax of a program. Then you can expect a system design interview, which is a little more high level, not so much in the code, but need to understand that you can plan a complete technical solution from 0 to 1. That you understand the considerations from a security aspect, from a usage aspect, from a cost perspective. Like, do you need to create or provision a VM that is online 24/7 for a batch process that runs Monday through Friday between 9 a.m. and 12 p.m. Maybe it's better to use some type of serverless function like Lambda or Azure Functions or Cloud Functions on GCP that can run a particular piece of code very quickly and do what needs to be done, but not hold on to those resources for the times when it's not going to be useful and you have a bunch of unused capacity inside of your computers, because that unused capacity is costing you money. So being efficient with resources, that's what the system design interview is going to do. And another aspect of the system design, and also the behavioral interview that is usually the final, or sometimes you may have a few behavior interviews or a few system design interviews, where the interviewer wants to understand how you communicate and how you can effectively and clearly communicate your ideas to another person. Because software engineering is a team sport. You're for the most part, not going to just be one developer in a room in a cave just writing and cranking out code. At this point with AI, we have code writing engineers or code writing tools. That's not even the most difficult part of engineering. The difficult part of being an engineer is understanding when should I even use a particular piece of code. How extensible should I make this function? Should I separate these two functions into two because they're doing two completely unrelated things, or maybe I can run this aspect of the code independently of this aspect inside of an asynchronous computation. And so the design aspect of software engineering is what they're at the system design phase of the interview. Is what they're testing for. You need to understand your understanding of not just the code itself and knowing how to write code and understand the syntax, but do you know how to take that code and turn it into a business solution that applies and aligns with the business outcomes that we're looking for? And then the behavioral interview is really just to make sure you're not a weirdo and make sure that you understand how to be honest. You understand how to deal with challenges and disagreements with your team, because no one wants to work with someone who doesn't take feedback well, and no one wants to work with someone who is a one-man show, right? You want to, when you're hiring someone or bringing someone into your team, you want to make sure that you can work with this person on difficult problems late at night when there's an emergency. So you have to, as best as possible, screen for that. And so that's what all of these multiple rounds of interviews are doing. But with that being said, something that I'm really looking forward to and trying to get going myself is kind of bypassing at least the coding interview aspect, because I know a lot of us are not good with timed exams. There's a reason why schools are kind of getting rid of the standardized SATs and ACTs. It's because that doesn't determine if you're good at, or you're a good thinker, a critical thinker, because you're putting unnecessary stress on someone because they have a timer that is saying, hey, I have to get this done in this amount of time. That doesn't really test for what you think it's testing for. And so that's one of the reasons why I put out a lot of my content online, actually showing, hey, this is how I code. I clearly know how to read and write code. Of course, I use ChatGPT sometimes to write the code for me, but then I go through and read that code to make sure it's not introducing any type of unnecessary variables or complexity into my code base that's going to make it less efficient for me in the future. So I try to make it super clear that I understand coding, and then some of these types of conversations that I have with people, and even showing my system design sessions where I'm actually thinking through a problem end to end and seeing, all right, what are the requirements I need from an engineering perspective to actually fulfill the requirements that this business use case needs. So I put out a lot of that content online so that hopefully a person who wants to work with me, is interested in working with me, I can point them to that resource and say, hey, don't give me a coding interview to determine if I know how to code. Check out all of the content that I put online on YouTube, on Substack, where I put numerous tutorials on how to implement and integrate Flutter with a auth system like AWS Cognito. I put a bunch of code online where you can see I know how to code. And I put a bunch of videos online where you can see I understand how to speak to people and I understand how to work through difficult problems from a high level and to a low level. So don't ask me to do a coding interview because I can do way better things with my time. That's just my, I really do not like those types of tests because they don't, in my perspective, do what the people think they're really going to do.
When is it too late to get into coding?
So, the best time to plant a tree was 10 years ago. The next best time is today. And so, I will never say it's too late to get into coding, whether you are a person in your 50s or you're either starting college or just getting out of college and you were studying something totally different, or if you're in your student or child inside of middle school at the lowest, middle school, although there are some elementary school students that are playing around with coding concepts that early. It's never too early or never too late to understand how a computer works. In 2025, we are not becoming less attached to computers. We are every day becoming more and more integrated with technology into our society, from your phone to the tools that you use to make payments. For your tax bills or your water bill, like you're paying online for things. I was just mentioning earlier inside of the episode the smart contracts and how that's going, and tokenization, and how that's going to change asset ownership in the next 10 and plus years. It's never too late to understand coding if you decide to be a coder or a programmer. And that's like the same as saying like you want to be an engineer, and I say an engineer like an electrician or a plumber. You can always learn how to do a bit of plumbing. That doesn't mean you're going to make plumbing your full-time job. You can always learn how to change a light bulb or change a socket or a fixture. That doesn't mean you're going to start going into commercial buildings and providing those services. But understanding what code looks like, understanding that, hey, how does the wiring in my house work? What is the difference between direct currents versus alternating currents? I guess a lot of you don't understand that difference, but these are some things that, if it lives around you all the time, you might as well know how to work with it. You might as well learn how to use it to make your life easier. So, it's never too late. I was in a middle school last week, talking to the kids, doing what, the KD, the biggest, does best. We give back to the community. We make sure they understand that coding is cool, because ain't nobody cooler than me. We was talking to them, making sure they understand what engineering is, understanding that they can get started with coding and engineering even where they are today. It doesn't have to be a super large project. You don't have to build Amazon right out of college. You don't have to build AWS right out of college. But you should, even in middle school, understand how computers work. Understand the syntax of a computer. Because even when we're talking about AI, yes, we can talk to AI in a normal, and I say normal as in English, human, understandable, high-level language. But they're still computers. There are still aspects of engineering that can help you and improve your prompt engineering when you're talking to these different chatbots and tools. And if you understand those concepts, no matter where you are in your career or your life, you're going to have a better time dealing with these different computers and how they work. And so, again, it's never too late. Get started now if you haven't. Reach out to me if you're interested. I love talking about computers and technology and engineering because that's all I do. And it's fun to me. I even married a software engineer because I wanted somebody to make sure. I wanted someone who could have a conversation with me about the things that I wanted to talk about and get my nerdy jokes. And so I love to have those conversations. Reach out if you have any questions. I am, looking for those types of conversations, and I would love to answer them. And some final thoughts. I actually saw a video on Instagram over this week with an older gentleman making an argument that there were certain traditions and habits that were deteriorating inside of American families. And those included sitting with your family for dinner, visiting your grandparents on Sundays, walking in the evenings, not for exercises, but with your friends and family just to have a conversation and spend some time side by side. Friday night movie nights in the living room with your cousins and your friends, and real conversations that require full attention and no multitasking. And that made me think about my life and how I'm using my time. And even the fact that I was just saying how interested I am in technology and innovation and using computers to do things that we've never done to make life easier. That is totally my goal and objective in this world, to use my skills and abilities to create systems and infrastructures that my community can use to grow and empower themselves. And I truly believe that technology is the way to go, is the path that we can use to gain that freedom. But I don't want my reliance or our reliance on technology and our belief in technology to be the reason we're not connecting with our families like we used to. And I don't know if it's just the age thing, right? Like, it's not just you grow up and you stop calling your cousins or you stop hanging out with your friends. There are other aspects and levers that make it more difficult to connect, right? You may start growing your family. You may move away. You may have your job. And things can be distracting to you. But I know that I would hate for the technology and modernization that we're building to come at, or for my family and the good relationships to come at the expense of that technology and modernization. And so it's a balance that I want to consider and stay mindful of in my life, because yes, we're closer to cyborgs than we are to our ancestors, but we can actually use technology not to disconnect, but to have more meaningful connections with each other. And so as you're going through this week, think about all of the ways that technology can help you become more human in your life and not more connected to the computers that we are using. So it's something I'm going to keep in mind, and I hope you do as well. Thank you for joining for this week. I appreciate your time, your energy, and your attention. Let's continue to build. Let's continue to learn and make our work impactful to the community in a positive and great way. So peace out. Stay great. Stay happy. Stay amazing. And I will see you next week.